Hey there, welcome back. We're going to finish up lesson 1.1 today, and we're going to start by talking about how to apply the operations of addition and subtraction to fractions. So here we go. Adding and subtracting fractions with the same denominator. I'm going to highlight this. This is the key, same denominator. When you have the same denominator, you have divided your whole thing into equal parts. So if you have 7 in the denominator here and 7 in the denominator here, you have like things or equal parts, all right? So when you have the same denominator, all you have to do is apply the operation that's indicated to the numerator, to the numbers in the top only, but not the denominator. You just carry that number forward, all right? So let's try a couple examples. I have 3/7 plus 4/7, all right? So 7 is my common denominator. I just carry that forward, and all I do is add my numerators together. 3 plus 4 is 7 over 7. And anytime you have the same number in the numerator as in the denominator, that always simplifies to 1. So you can write 1 in terms of any kind of rational number. Example B, 3/7 minus 4/7. Well, again, we have a common denominator of 7, all right? So we're in equal parts, so all I have to do is apply my operation to my numerators. 3 minus 4 is negative 1 over 7. That's my final answer. Always check to see if you can simplify or reduce any further. In example C, the technique that I want you to use, because I want to build on the skills that we've been learning, is whenever you have a mixed number, I want you to convert it to an improper fraction first, and then if you need to, go back. All right? So I have 6 times 2 plus 5, that is 17/6, plus 6 times 3 is 18, plus 2 is 20, plus 26. Now I have a common denominator, so all I have to do is add my tops together, and I get 37 over 6. Does 6 go evenly into 37? No. Is 37 divisible by 2? No, it's not even. Is it divisible by 3? No. 3 plus 7 is 10, which is not a multiple of 3. It's not divisible by 5, so this is reduced. Okay? All right, if you wanted to rewrite it back in a mixed form, you would go and do long division, and you would have 37 divided by 6. That goes in 6 times with a remainder of 1. Okay? So this is 6 and 1/6. Either one of those answers is acceptable. In example D, I've used the exact same numbers, only I've changed the operation to subtraction. So I'm going to carry down my numbers that I converted up in C, and I'm going to subtract. All right, I have the same denominator, which is good. Now, 17 minus 20, well, that's negative 3. Now be careful, you always want to ask yourself, can you reduce further? Does 3 go into 6? Yes. So I'm going to divide top and bottom by 3, and my final answer is a negative 1/2. All right, if at any point in any of these lessons that you feel you don't understand something, just hit the pause button and go back and replay it. All right, in order to add and subtract fractions that don't have the same denominator, then we have to learn how, or remember how to write equivalent fractions. We've touched on this, and we're going to use it again here. Remember that we can write equivalent fractions by multiplying both the top and the bottom, must be both, of a fraction by the exact same non-zero number, right? You make equivalent fractions by multiplying the numerator and the denominator of a fraction by the same non-zero number. So let's see what this looks like. We are going to be asked to convert the following fractions into an equivalent fraction with the indicated denominator. All right? So in problem number 1, we want to rewrite 2/3 as a equivalent fraction with a denominator of 12. So remember, when we're doing equivalent fractions, we're multiplying. What do I multiply 3 by to get 12? Well, that's 4. So that means I have to multiply 2 by 4, and that gives me 8. 8/12 is an equivalent fraction to 2/3. Number 2, I want to rewrite 3/4 as an equivalent fraction in 20ths. So what do I have to multiply 4 by to get 20? Well, that's 5. So that means I have to multiply 3 by 5, and that's 15. The equivalent fraction is 15 out of 20. Why don't you hit a stop for a second, and I want you to do 3 and 4 on your own, and then come back and see if you got them right. All right, welcome back. For number 3, in order to rewrite 8/3 as an equivalent fraction in 9ths, I had to multiply my denominator of 8/3 by 3. That means I had to multiply 8 by 3, and that gave me 24/9. The equivalent fraction in 9ths is 24/9. For number 4, hopefully you realized that you had to multiply 5 by 3, and then you went ahead and you multiplied 16 by 3, and you got 48/15. 48/15 is an equivalent fraction to 16/5. Remember, equivalent fractions look different but have the same value. All right, now we're going to use the techniques from slides, the first few slides, and we're going to add and subtract fractions with, keyword here, different denominators. So now our fractions won't have the same denominator. We're going to have to make them have the same denominator. So we're going to do that first by finding a common denominator. Right? We're going to find the common denominator. In order to do that, you're going to first look to see, just like we learned before, does my smaller number go evenly into my bigger number? If yes, then the bigger number is automatically your common denominator, and that step is done. If no, then you're going to start thinking about multiples of the bigger number, the bigger denominator, and see if your smaller number goes evenly into any of those. Okay, we'll pick that up on some examples. After you found your common denominator, then you want to convert one or both, if necessary, of the original fractions into an equivalent fractions with that new common denominator. Then, once you have the common denominator, you're going to apply the operation to the top numbers, but not the bottom numbers, okay? And then you're going to reduce the fraction when needed. All right, let's add 3/2 plus 4/8. Do I have a common denominator? No. I need to find a common denominator. So I ask myself, does my smaller number 2 go evenly into my larger number 8? It does. So that means that 8 is my common denominator. All right? Now what I want to do is I want to rewrite any fraction that doesn't have a denominator of 8 into one, an equivalent one with 8. So here, you notice that 4/8 already has a denominator of 8, so we don't have to change that. That's the point I was trying to make. But 3/2 I do have to change. So what do I multiply 2 by in order to make it 8? Well, that would be 4. So that means I have to multiply 3 by 4, and that gives me 12. All right? Now I have the common denominator, so all I have to do is combine my tops according to the operation. 12 plus 4 is 16, so I get 16/8. Now I ask myself, can I reduce that? Does 8 go evenly into 16? Yes, it does. So I'm going to divide top and bottom by 8, and I get 2/1, which is equal to 2. And that's the reduced, most simplified version of the answer. All right, let's keep going. Let's try one that has the operation of subtraction. Okay? Again, I have different denominators, so I have to find a common denominator. So I always ask myself first, does 3 go evenly into 7? No. So 7 can't be my common denominator. So now I have to look for multiples of 7 that are common to 3. Well, with 3 and 7 both being prime, you can jump right to it just by multiplying them together. So 7 times 3 is 21. That's my common denominator. Now I'm going to convert each of those fractions into an equivalent fraction with a common denominator of 21. Okay? Now, what do I have to multiply 7 by to get 21? Well, that's 3. So that means I have to multiply 3 by 3, and that gives me 9. Now the next fraction, what do I have to multiply 3 by to get 21? Well, that's 7. So that means I have to multiply 2 by 7. And 2 times 7 is 14. Now I have my common denominator. I can combine my tops. 9 minus 14 is negative 5 over 21. I need to check to see if I can reduce. 5 is a prime number, and 5 does not go evenly into 21, so this is simplified. Now we're going to try some examples that start with mixed numbers. So there are other ways to do this, but I want you to write the mixed number as an improper fraction. So my first number, 2 and 5/4, I go 4 times 2 plus 5. That is 13 over 4. My second number I write as 6 times 3 plus 2. That is, 6 times 3 is 18 plus 2. That's 20 over 6. Do I have a common denominator? No. So I have to find one. Does 4 go evenly into 6? No. So now let's start thinking of multiples of 6. Go through the 6 times table and check to see if 4 goes into that. So I have 6 times 2 is 12. Well, 12 is divisible by 4, so my common denominator is 12. So now I'm going to rewrite each one of my fractions as an equivalent fraction with a denominator of 12. All right? What do I have to multiply 4 by to get 12? 3. So that means I have to multiply 13 by 3, and that gives me 39. My next fraction, what do I have to multiply 6 by to get 12? Well, that's 2, so that means I got to multiply my numerator by 2, so 20 times 2 is 40. I have the same denominators, which allows me to be, I'm in equal parts now, so now I can just add my numerators together, and I get 79 over 12. And you can leave it in this form. We have to check to see if it's reducible. Does 12 go evenly into 79? No, because 12 times 6 is 72, so there would be a remainder. Does 2 go into 79? No. Does 3 go into 79? No. Does 4 go into 79? No. And neither does 6. So this is the reduced form. If you wanted to write it as a mixed number, then you would divide 79 by 12, and you would get 6 with a remainder of 7. So the final answer in mixed numbers is 6 and 7/12. You'll see in the applications there will be times where it makes more intuitive sense to convert it into a mixed number. And here are some of those applications. Okay, let's read them first, and then we'll try and figure out key phrases to help us realize what to do. Golf tees come in many sizes. The longest tee is 3¼ inches, and that is allowed by the USGA rules of golf, is called the Pro Length Max Tee. If another club called the short tee is 2 1/8 inches long, how much longer is the Pro Length t than the short t. Key phrase here, how much longer. When we see that, we have learned in the past that that means subtraction. How much longer? What's the difference? All right? All right, so we're going to subtract our longest minus our shortest. This is 3 1/4 minus 2 1/8. And again, there are other ways to do this, but we're going to write it in improper fraction, and I get 13/4 minus 17/8. I'm going to find the common denominator, which is 8, and I'm going to convert 13/4 into an equivalent fraction in eighths, and that means I have to multiply top and bottom by 2, and that gives me 26. My 17/8 I don't have to change. Now I can do my subtraction on the top, and I end up with 9/8. Now 9/8 is not an intuitive number for many of us, so we want to convert it into a mixed number. I'm going to divide 9 by 8, and I get 1 with a remainder of 1. So I have 1 1/8 inches longer. This next application, we want to find the perimeter of the triangle. You have to remember what perimeter means. Perimeter means it's the sum of all the sides. It's the sum of all the sides. So it's the distance around. Perimeter is this side plus this side plus this side. All right? So we have to add all of those mixed numbers together. So to do that, I'm going to go ahead and start converting them into improper fractions. So I'm going to start here, and I get 21/4 plus 7 1/2 is 15 halves, plus 10 1/8 is 81/8. Okay? I have to find a common denominator because they're all different. So I go through my smaller ones and I see if they go evenly into my bigger one. Does 2 go evenly into 8? Yes. Does 4 go evenly into 8? Yes. That means that my common denominator is 8. What do I have to multiply 4 by to make it 8? Well, that's 2. So that means I have to multiply 21 times 2. So that gives me 42/8. What do I have to multiply 2 by to equal 8? Well, that's 4. So that means I have to multiply 15 by 4, and that gives me 60. And then 81 just stays the same because I haven't changed that denominator at all. Now I add up all of my numerators, and I get 2 plus 0 plus 1 is 3, 4 plus 6 is 10, plus 8 is 18. I get 183/8. Okay? So let's convert it to a mixed number so we get a better feel for it. And when we do, it goes in 2 times. That's 16, remainder of 2. Bring down the 3. That's 2 again. That's 16, remainder of 7. So that is 22 7/8 feet. That's what the perimeter equals. Probably should have started off by writing P up there too. Okay? Perimeter equals the sum of all the sides. All right. Let's talk about this next application. Mrs. Pilger's favorite recipe for brownies calls for 1 3/4 cups of sugar. If she has 15 1/2 cups of sugar on hand, how many batches can she make? All right, why would Mrs. Pilger even want to know this? Well, think about what she does. She has to have supplies for every kitchen in her classroom. For every team of students, she divides her students into teams, and they each have their own kitchen. They each make their own batch. So she has to be able to know how much she has on hand and how much is required for each, so she can determine if she has enough. All right? So she wants to take 15½ cups, all right, and see how many groups of 1 3/4 cups she can have. How many groups? Well, that's a division. That's a division. Division takes something and divides it into groups. So we're going to divide 15½ by 1 3/4. I'm going to convert each of my mixed numbers into an improper fraction. My numerator then becomes 31/2. Then I have a big division sign, and then my denominator becomes 7/4. All right? Now, we use the rule to divide fractions as keep, change, flip, right? But we normally see this as 31/2 divided by 7/4. These things, these two expressions are equal, all right? This is our keep, this is our change, this is our flip. In this form, the numerator is the keep, this big division sign, that's your change, and the lower fraction is the flip. So I'm going to take 31/2 times 4/7. I'm going to cancel my 2 into my 4. And then when I multiply, remember, I just multiply straight across both the top and the bottom. So I get 62/7. And then I'm going to divide this out to get a mixed number. And I get 8 6/7. So this is 8 6/7. So in a pure mathematical standpoint, she can make 8 batches of brownies with the sugar she has on hand. If she needs more than 8 batches, then she's going to have to go buy some more supplies. All right. Last slide, working with circle graphs. All right. What a circle graph does is it takes a population. In this case, we're looking at worldwide internet users, and that is 970 million, and it divides it into proportions. So in this case, of the 970 million, okay, 23/100ths are users in North America. 7/20ths are users in Asia. 3/10ths are users in Europe. And then there's this other piece that we don't know what that proportion is or what that ratio is. All right? But here's what we do know about a circle graph. All of the pieces have to add up to the equivalent of 1. Remember, 1 is going to be the same number in the top and the bottom. All right? So the first thing that we have to do is find out what these 3 pieces add up to. So in order to do that, I'm going to add them together, and I'm going to have to find a common denominator. So I have 23/100 plus 7/20 plus 3/10. All right? Does 20 go evenly into 100? Yes. Does 10 go evenly into 100? Yes. So my common denominator is 100. All right, my first fraction here that I've written doesn't have to change at all. It's already expressed as a fraction with 100 in the denominator, so I just carry that down. Now, what do I have to multiply 20 by to get 100? 5. So that means I have to multiply 7 by 5, so that's 35. And what do I have to multiply 10 by to get 100? Well, that's 10. So that means I have to multiply 3 by 10, so plus 30. If I add all those up, I get 88 out of 100. Okay? So remember, this 88 out of 100 plus this other out of 100 has to equal 100 out of 100. So what does this other piece have to be? 12 out of 100. Does that reduce? Yep. I'm going to divide top and bottom by 4, and I get 3 out of 25. So this other is 3 out of 25. The next question it asks is, calculate the number of users in North America. So you might want to get a calculator out for this. All right. How you do this is you take your total population, which is 970 million. So that means you write 970, and then you have to write 6 more zeros after it, times 23 out of 100. And I'm going to use my calculator to find that number. And so I get 970,000,000 times 23 divided by 100 equals. I have 223, I hope I have enough room for this, 223,100,000. That's my final answer. 223,100,000. Okay? All right. These are the problems that we're going to work tomorrow in class. Thanks for listening. I hope you have a great night. See ya.